Alright, let's finish this off. So I'm going to solve this diffie-q. So instead of f prime at x, I write dy by dx. There's your first step. And then we need to separate the variables. So the y's will be on one side and the x's. So I'm going to divide by y, and I'm going to multiply by dx. And then I'm going to integrate this. So on the left is the logarithm. On the right, you actually could do this both ways, but this is why you could actually put the exponent 2 divided by 2, or you could integrate each one individually, which is what I did. Both will give you the same correct answer. And at this point, I'm going to plug in 1, 1. So we have 1 for y and 1 for x. I'm going to solve it for c. So ln 1 is 0. This is 1/2, take away 2. You could write it however you want, but I'm going to add that to the other. So you could either say 1.5 or 3/2. Both are a good answer. And then I come back here and go ln y. That's x squared over 2 minus 2x. I'm just going to write 3/2. And then write it as an exponential. Realize that could be either positive or negative. And because the point given was positive, the y-coordinate is positive. There's my answer. Evaluate this. When you have a derivative and integration, this is the fundamental thermocalculus, they cross out. And it makes it a substitution question. So if I substitute -1 in and then take the derivative, that answer is 0, because it's a constant. If I plug 2 in, so where there's an x, I'm going to plug in 2x. And then the derivative of 2x is the hook. And there's your answer. So you substitute in and then take the derivative, and that's your hook. Here, the derivative integration, they cross out, undo each other. Again, it's a substitution question. Pi is a number. If I plug in, it gives me 0. E is a number. If I plug in and take the derivative, it gives me 0. This answer is just 0. All right, one more. So we're looking for algebra to plug in. So we're going to plug in tangent x, and then we're going to plug in cosine x. Oh dear. Let's try this right, because I need to do with the hook. So let's do this right with the hook. So it's going to be 3 tangent x plus 1, and then the hook is the derivative of tangent, which is secant squared, minus, and then we do 3 cosine x, and then the derivative of cosine is negative sine. So remember to plug in, and then the derivative is the hook. To plug in, and then the derivative is the hook. All right, last page. We did this in class. So the velocity here is 30 miles per hour at 245. At 115, it's also 30 miles per hour. And you could write sentences for that for sure. What's the acceleration at 430 is the slope. Now we change 430 to say 330 because 430 is off our graph. So at 330, what's the slope of this line? And we go down 10 and to the right 1. So it's negative 10 mile per hour or negative 10 miles per hour squared. How do you integrate off a graph? You find the area. So you find the area of the triangle. That's half the base times the height. You find the area of the rectangle. So the base is 2 times 30. And then the last one is a trapezoid to find the area of. So we start with 1/2. The base of the trapezoid is 1. And then the heights. So the first height is 30, and the second height is 20. You add the heights, and then if you calculate this, you get 100. And then what does that mean in terms of it? That's the distance traveled. So from noon to 4 a.m., a total distance of 100 miles was traveled. Again, that was done in class. Our last one. The height of a right triangle is expanding at a rate of 3 centimeters per minute. And it's positive because it's expanding. The base is always twice the height. And it says find the rate of the area. So we know area is half the base times the height. Now we have too many variables here. So instead of base, we know the height. So we're going to write everything in terms of height. So the base is 2h and the height is h. And I'm going to simplify this. So 1/2 times 2 is 1h times 8. That's just h squared. Then I'm going to take the derivative of that with respect to time. So the derivative with the hook, dA by dt. The derivative 2h and needs the hook, dH by dt. And then I'm going to plug in the values that I have. So it says the height is 10. So we're going to plug in 10 for the height. The height is expanding. The rate of it is 3. And that's going to give me the rate for the area. So that answer is 2 times 10 times 3. And then the correct unit would be centimeters squared for area per minute for the rate. You can write a nice sentence for that. So when the height of the triangle is 10 centimeters, the area is increasing at a rate of 60 centimeters squared per minute. And it's increasing because the answer is positive. All right, Mr. G Math over and out. Good luck on the exam. You can do